So inconsistent, question 1, we're doing the exam, the past exam, December exam. Inconsistent is the same thing as no solution. So the first thing you need to do when you're given such a matrix, you need to make sure that it's in row echelon form. In this case, you've got this matrix. You go to the first row, you highlight your first number there. In this case, my first number is 1. My 1 will be my pivot point. And then below my pivot point, do I have zeros? Yes, great. I move on to the next row. I highlight my pivot point. In this case, it will be -1. Below -1, below my pivot point, do I have a 0? Yes, great. That means this matrix is in row echelon form. So what we need to do is to focus on these two last numbers. For no solution, there are two conditions. K squared minus 2k minus 3 must be equal to 0, while k minus 3 is not equal to 0. And then we solve this. This will be k minus 3, k plus 1, which is equal to 0. K is equal to 3, or k is equal to -1, right? Now we've got two k's here. Of course, condition 1, condition 2. Of course, this case, we got them from condition 1, so they satisfy condition 1. If we take any of them, we plug it in here, we're going to get a 0. But now we need to figure out if they do satisfy condition 2. We're going to start with K3. We take K3, we put it here, we get a 0. But the condition says this number that we get here must not be equal to 0. So this one is not valid. Not valid. And then we go to K is equal to -1. If we plug in K is -1 here, we're going to get -4, which is not equal to 0. So this condition, if we plug it here, it's going to give us 0, which we want. If we plug it here, we're not going to get a 0, which we want. So this is correct. Our condition is this one. K must be -1 in order for this thing to be inconsistent. So if we do check our solutions here, we have to look for k is equal to -1. Well, this one is wrong because it says the correct answer is k -1, and it uses an and here, which means both of them should be correct at the same time, should be true at the same time. This one is not correct. This one is not correct as well. This one is the one that's correct. And the reason why this one is correct is because for when you have an or, the whole statement becomes true. The whole statement becomes true only if one of the statements, the sub-statements, are true. In this case, k is equal to -1, it is true, but k is equal to -3 is false. But because this one is true, it makes the whole statement true. Unlike here there's an and. In order for the whole statement to be true, both your sub-statements must be true. So in this case, our answer was supposed to be this one. Let's move on to the next question. It was question 2. Let's move this one. Why not this one? Yeah, just post it of it. It works fine for me. And then how do I delete this whole thing? Delete. Wait. And then we do it. Oh, that's good. And now this was possible. Question 2. Given two square matrices A and B of the same size, then find the expression A minus B, where A minus B squared the same thing as A minus B, A minus B, which is equals to A squared, A times A, then A, gonna be AB, then we come here, minus BA, and then plus B squared. Then this is your answer. You can't add these two because AB is never equal to BA when it comes to matrices. And numbers, that is true. That is true. But in matrices, it's not true. So the correct answer is this. So we check our solutions here. The correct answer here was this one. This one is supposed to be the correct answer. Then let's check another question. Question 3. Yeah, question 3. Question 3, consider the matrix below with X is equal to AB, where A is this and then B. For which values of K will entry X2 didn't copy this thing correctly, did I? Let me check again. Yeah, I wonder why it's not posting it correctly in here. Let me just do this. Paste it. On it. Small. Yeah, much better. Yeah, there it is. Oh, much is happened here. It's fine. And I think we can work with it. So yeah, we are back. So yeah, this is the dead question. Everything is appearing. For which values of K will the entry X2, 3 be 0? So X is equal to AB. So X is equal to AB, right? And then our A is this matrix 1, 2, minus 1, 4, 3, minus 1, 1, 3, minus 2, 5, minus K plus 1, then B. B is 1, 0, 3, minus 2, 2, 4, minus 1, 5, minus 1, 1, 1, K, minus 1. Right. So before this, you can see these two matrices. are supposed to be multiplied together. Before you can even try multiplying, you need to figure out if they can be actually be multiplied. So this is a 1, 2, 3, say 3 by 4. Say 3 by 4. And then this one is a 1, 2, 3. It's a 4 by 4. 4 by 4. For this to be possible, these two numbers must be the same. And then that means our answer will be a 3 by 4 matrix, right? But here we're not interested in the whole thing. We're interested in x 2, 3, right? Because you're gonna get a 3 by 4 matrix. So you're gonna get 1. You're gonna get this line 1, and then you're gonna get 2, and you're gonna get 3. Then we're gonna get 1, 2, 3, 4. It's gonna be something like this. 1, 2, 3, 4. 1, 2, 3. 1, 1, 2, 3. So let me just delete this. Something like this. 1, 2, 3. So we're looking for entry 2, 3, which means it's gonna be in row 2, and then row 2, column 3. We're looking for this entry. We're looking for this entry here. And then this entry here, we can get it by multiplying row 2 with column 3. So where's row 2? There is row 2. Column 3, there is column 3 here. So when you're multiplying matrices, we normally say this would be 3 times minus 1 plus minus 1 times 1, and then this one multiplies the other one plus 1 times 1, then plus this 3 multiplies this one, 3k minus 1, which is minus 3 minus 1 plus 1 plus 3k squared minus 3k, which is equals to, these ones will cancel out. This is equals to 3k squared minus 3k minus 3. This will be our x 2, 3. But we need to find the values of k for which this n3 would be equal to 0. So this n3 must be equal to 0. It means we have x 2, 3, which is equal to 3k squared minus 3k minus 3. This must be 0. So we need to find k. We divide everything by 3, we get k squared minus k minus 1. And if you solve this, I'm going to solve using, this would be minus 1 plus negative root b squared, in this case is 1 squared, minus 4a is 1, and then c is minus 1 over 2 times 1, which is equals to 1 plus, this is 1, and this will be plus 5, sorry, plus 4, all over 2, which is the same thing as 1 plus root 5 all over 2. And when you check here, here is our k. This is the answer. And we move on to the next question. Right. The next question would be, what's it? Number 3 is number 4. Yeah, number 4. Number 4 is number 4. So number 4 is asking, it's almost similar to question 1, but now we have to do a little bit of work. We need to find the values for B for which the system has no solution. So basically the system is inconsistent. I'm just gonna write the matrix here. You always go to the first row, right? Let me just write it here. B plus 2. Let me write the augmented matrix so that it looks cleaner. And we've got 0 here. Got 1. Got 1. We've got 3. Got 0 here. We've got minus beta minus 3. And then because it's augmented, we need to append the answers here. That's a definition of augmented matrix. It means you append the answers this side. If it's not augmented, if it's not an augmented matrix, then it doesn't have this. So the first thing we need to do, you first go to your first row, because in order for you to solve this system, your system must be in row echelon form. In this case, as you can see, it is not. So you need to go to the first row. Okay, there's my first row, and then I highlight my pivot point. My pivot point must not be equal to 0. When you look at this first line, we don't know if this number is 0 or not. So I would advise you not to choose it because you don't know if it's 0 or not. We can just choose to exchange it with this dead one because we know 3 is not 0. But with B plus 2, we can never know. That it depends on what B is. It's minus 2. 0, this remains 1, 1, minus 1, B plus 2, minus 1, 3, 8, right? Okay, you highlight our pivot point, and then you must make sure the numbers below our pivot points are 0. This one is 0, good, but this one is not 0. How can you get this one to be 0? Let me just, I'm just going to include the second step here. How can we make sure that our pivot point is equal to 0? I'm sorry, this number below the pivot point is equal to 0. In order for us to make this number equal to 0, we need to make both these numbers the same. How can we do that? One way is to divide everything by 3 and then, but that one will be complicated. You don't want to complicate your life like that. The simplest way here is to just multiply this one by B plus 2 and then this one by 3. So it will be row 1 multiplied by B plus 2, right? And then row 3 multiplied by 3. This will give a matrix of, this will be 3B plus 2. This will be 0. This will be minus B plus 2, B minus 3, and then minus 2, B plus 2. We've got a 0 here, we've got a 1, we've got a 1, we've got a minus 1. And then here we're multiplying by 3, so it's going to be 3B plus 2. And then we've got minus 3. We've got 3 times 3, which is 9. Then we've got 3 times 8, which is 24. Right? And then we move along. Now we need to get this thing 0 because now they're the same. So we just add now. We subtract. So we're gonna say R1 minus R2. We can say R2 minus the same thing. So what am I gonna get? This remains the same. Plus 2. 0 minus B plus 2. B minus 3. Minus 2. B plus 2. Then, okay, this one is fine. Don't need to change it. Minus 1. Then 3. This one minus this will give us 0. 0 minus this will give a positive 3. Then this minus this will give a minus B plus 2, B minus 3, minus 9. Then this one would be minus 2, B plus 2, minus 24. And then we are done with this pivot point. You can even make it cleaner by removing this thing because it's a common factor. Now we go to the next pivot point. You highlight it, it's 1. Right? And now, in order for me to remove this 3, because below the pivot point I need a 0, I do the same thing, but in this case, I'm going to multiply this one by 3 so that these two numbers are the same. So I'm just going to say 3 times row 2. This will give me just remove. Let me do it here. Do this one as well. So yeah, we will say 3 times row. We will say 3 times row 2. This will be, yeah, I'm just gonna, because we're done using this one as well, I can just remove that common factor so that it becomes cleaner. Minus B, minus 2, minus 3, minus 2. It's got a 0. We've got a, now we're multiplying row 2, so that's going to be 3. And then we're going to have a 3 as well here, minus 3, and 0, 3, and then this one, let me just clean it up a bit here. Actually, I can just leave it like this. Minus B plus 2, B. No, let me clean it up. Yeah. Let me clean it up. So this one will be negative B squared minus B minus B minus 6 minus 9, which is the same thing as minus B squared plus B plus 6 minus 9, which is minus B squared plus b minus 3. So minus b squared plus b minus 3. I'll just check everything's correct. Yeah, minus b. Yeah, that's correct. Then this one we change as well. It's gonna be minus 2b minus 4 minus 2b minus 4 minus 24, which would be minus 2b minus 28. So minus 2b, but it's gonna be fast when doing this thing. So now these two numbers are the same. I can get rid of this one by saying R2 minus R3. That will give me a matrix of this one will remain the same. Minus 3, minus 2, it will be 0, it will be 3, it will be 3, minus 3. 3 minus 3 will be 0. And 3 minus this, show you how it will be at 3. So it's 3 minus b plus b minus 3 will be 3 minus plus b squared minus b plus 3, which is b squared minus b plus 6. So b squared minus b plus 6. Then now negative 3 minus this one. So minus 3 minus 2b minus 28 will be minus 3 plus 2b plus 28, which is there will be 2b plus 25. Then now we are home and dry. The matrix is in row echelon form, so now we could do something with it and start answering the question. Otherwise, if it's not in row echelon form, you can't answer the question. Right? Or maybe you could. Who knows? But yeah, that's how it is. They say the system has no solution. So go with our conditions. No solution. Condition 1, b squared minus b plus 6 must be equal to 6, while condition 2, 2b plus 25 must not be equal to 0. So when we solve this one, you can see that this cannot be solved. We can't get the real solution, because if we try to find s minus 4ac, this will be minus 1 squared minus 4a6, which will be 1 minus 24, which is minus 23. See, this number is negative, and you know when you're trying to solve for b, this whole thing will be inside a square root like this, and that means you cannot find real solution. And because of that, there's no such value of b. This one is the correct one. This one. I will just have to check again if I did everything correct with the matrix, but at the moment, this is the correct answer. All right, let's move on to the next one, which will be, this was question what? This was question 4, so let's check question 5. question 5. Oh, question 5. Let's question 5. Copy. Move everything here. Right. Right. Oh no. I'm going to copy it again. Question 5. Yep, there it is. Solve for question 5. Consider the two matrices, X and Y. The values of Y for which their matrices XT and Y have no inverses are given by, well, there are two ways of solving this question, and I'm just going to go with the obvious one. Let's find XT first. XT exchange. This is one number, minus 1. We exchange the rows with the columns. This row becomes a column, and then this row becomes a column. However, nothing changes really, because this matrix is symmetric. And then Y, here's Y. For these two not to have inverses, let me just put here. 5, 0, 0, 2x minus 3y minus 7. For these two not to have inverses, we know that the determinant of xt must be equal to 0, right? And what is the determinant? Determinant of a 2 by 2 matrix is just you multiply this 2, subtract this, the multiplication of the reverse diagonal. So this diagonal is 3x plus y minus y minus 0, which is nothing. So this must be equal to 0. And this side, the determinant as well must be equal to 0. So this is 5, 2x minus 3y minus 7 is equal to 0. This is 3x plus 3y minus 3 is equal to 0. This side is 10x minus 15y. This is 35 minus 35 is equals to 0. Can just divide everything by 3 here. Equal to 0. And divide everything by 5 here. Actually, I could have just divided here, man. Anyways, minus 3y minus 7. Yeah, the step was not necessary. So now we have two equations. We can solve them simultaneously or using elimination. I'm just gonna use elimination. So the first thing I'm gonna do here, I'm just gonna take this one and I'm gonna take this one and put it here. X and then plus y minus 1 is equal to 0. Equation 1. And then I'm gonna, because I want to use elimination, I'm just gonna multiply everything by 2 here. So it's gonna be 2, 2, 2. And then I say equation 2 minus equation 1. This minus this will be 0. This minus this will be minus 5y. Then this minus 7 minus 2 will be minus 7 plus 2, which is minus 5, equal to 0. And then this means y would be, if I take this, it's going to be -5. I divide it by, so it's going to be +5. I divide it by -5. I'm going to get -1. And then to find x, I'm just going to use this one, x, and then minus y, 1, minus 1 is equal to 0. It means my x is equal to 2. So I have x is equal to 2, and then y -1 for this to have no inverses. Okay, let's check the correct one. No such value of y exists, or x is equal to 2. The value of y, or we want y here, we only want y, we're not interested in the x. The value of y for which the matrix has no inverse. Where's y? Oh man, just happened here. Let me check the question again properly. If I didn't copy it properly. No such value of, yeah, this is the correct answer. This is the correct answer because there's no y is equal to -1 here. This will be the correct answer. And then we move on to the next question. Let's delete everything here. What? This was question 5, right? Question 5. Question 6. Oh, question 6. Let's skip question 6. We're gonna come back to it. It's a little bit long. Oh, wait, 7. Why is 7? It's not 7. Oh, there is 7. There is 7. There is 7. This thing is still recording. It is. Question 7. Let A be coefficient matrix. Well, coefficient matrix, it's not an argumented matrix, a coefficient matrix. So this will be 3, 4, 1, -2, 7, 1, 8, 1, 5. Yep, this is not an argumented matrix. It's a coefficient matrix. Coefficient number, it's a number that you find next to a letter. This number does not have a letter next to it, so it's not a coefficient. Here's our coefficient matrix. Let A be our coefficient matrix. Now add the following cofactor entries of A. So we need to add C21 plus C13 plus 3 C23. But before we can do that, we need to find what these numbers are. And in order to find cofactors, you need to find minus. So I'm going to find the minor of 2, 1, which is equal to, cancel this, cancel number 2, then cancel 1. I'm going to be left with 4, 1, 1, 5. Let me check again. I cancel this and I cancel. Sorry, I messed up here. Yeah, I did. I cancel this and then I cancel this. I'll be left with 4, 1, 1, 5 is correct. Then M 1, 3. I cancel this and I cancel this. I'm going to be left with -2, 7, 8, 1. Then M2, 3 is going to be, I'm canceling 2. Where is 2? There is 2. I cancel this and I cancel this. We have with 3, 4, 8, 1. And the answer for this will be 4 times 5 is 20, minus 1 times 1 minus 1, which is 19. Then this one will be 3 times 1, which is 3, minus 4 times 8, which is 32. And this will give us minus 29. Right. Then do the same thing here. Minus 2 times 1 minus 2 minus 7 times 8. 7 times 7 is 49. 49 plus 8, that's 50. 49 plus 8. 49 plus 7, 56. So minus 56. This will give us minus 58. So this implies that C 2, 1 is equals to minus 1, 3. Then we've got a 19 here. And then C2, 3 is equals to, basically, if these two numbers, when you add these two numbers, let me just do it. 5 and minus 29. And then this will be negative 19. And then this will give us a negative times a negative will be 29. Then C what? 1, 3 will be minus 4 minus 58. And then this will be positive, this will be negative, minus 58. Then we come here to find out the answer. C21, that's minus 19, plus C13, which is minus 58, and then plus 3 times minus 29. When you add all of this, you should be able to find out your answer. I think your answer should be minus 58 plus 3 times minus 29. So everything is correct here. Check again. Minus 19, no. Minus 58. Yeah, let me stop here. This is positive 29 because here's 23, 29. So this will be 10. Do we see a 10 here? Nope, there's not 10. So the correct answer is this one, none of the above. Yep. Let's continue to number 8. We're rolling. Cut. And then let's look for number 8. There is number 8. Oh, number 8, we did number 8, but let's just do it again. Let's just do it again. Because why not? So let A be a square matrix. Which of the following statement is correct? It's talking about skew matrices and symmetric matrices. For a skew matrix given A, for it to be symmetric, if we take the transpose of A, we must get A. It's a condition. If it's skew symmetric, if we take this the transpose of A, we must get minus A. That. So now let's answer this question. We need to figure out if the first one is skew symmetric. Figure out A minus AT. This is the first one, right? When it's transpose it, the whole thing. Let's figure out what it is. I'm gonna start with the inside T, the inside this one. So this one will be AT minus AT T. This is the outside T. This will give us AT minus AT, which is equals to A minus AT. And is this skew symmetric? Well, it is skew symmetric because this can be written as because in order for this to be skew symmetric, right, we know that this whole thing, the one inside, which is the original one, which is our A, given A, which is our given A, we want this after transposing it. See this, we want it to be negative. But this and this are the same. Let me show you. You don't believe me. And this will be AT, then minus A. If we distribute the A, we end up with minus AT plus A, which is the same as A minus AT. Voila, they're the same. So another way of writing this is writing it like this. So this option is correct, this one. This one, you can try do the same thing like this. You'll find out it's not skew symmetric. This one, it's also not, it's symmetric actually. This one would be skew symmetric, but here they are saying it's symmetric, so it's a wrong option. So your correct answer was this one. So how much time do I have left? Let's move on. Let's move on to question 9. Not everything, then let's look for question 9. Question 9. Oh, there it is. Great. Copy it. Sure. Question 9 says, let the matrix, there's the matrix. We need to figure out if we need to figure out options that are correct here. The first one says this matrix is in row echelon form. Well, let's figure out, let's find out. We go to the first row. We circle a number that is not 0. We cannot circle 0 and say it's our pivot point. So we're gonna go to the next one. So 1 would be our pivot point. And below our pivot points, do we have zeros? Wait, yes, great, good. move on to the next row, right? On the right, starting from here, on the right. That means our first number that we need to check is this one, 3. If 3 was a 0, we're gonna check the other one, but we start from here on the right of this one. 3 is a number, great. So we're gonna circulate as our pivot point. Below 3 is a 0, yes. So this is correct. So this one will be wrong because it says none of the given options, but we already have an option. Is this thing reduced? Well, in order for it to be reduced, we actually got 3, but this one there's no row, so we can't expect to have 0 because there's no other row below it. We have our pivot points above. There's no line here, so we can't expect it to be 0. There is a line. In order for it to be reduced above our pivot points, we must be having 0 and below 0. This one as well, we must have a 0 and a 0. So we don't have zeros. Well, reduce row echelon form or row echelon form. I talked about this earlier, about this word or. In this case, it's not reduced, but it is in row echelon form. This one is correct, this, which makes the whole thing correct because of this or. You know, if one is correct, the whole thing becomes correct. Reduced echelon form and the row echelon form. In order for this one to be true, both of them must be true. But this one is wrong. Doesn't matter about the other one. Even if it's correct, this whole thing will be wrong. So yeah, we are done with question 9. Move on to question 10. Question 10. Art question 2. Oh, 10, page 10. Question 10. I think very good job in this. So question 10 says, find the determinant of the following matrix by inspection. Well, as you can see, this one, we talked about this one. This one is a elementary matrix because as you can see, this is 3 times B. We have B because we did one row operation on on I3, I4 actually, I4. We did one 0 0 0 0 1 0 0 0 0 1 0 0 0 0 1. So to move from this to this, what we did was we said minus 3 times row 3 function. Then we got B, which is 1 0 0 0 0 1 0 0 0 0 1 0 and 0 0 0 minus 3. Then we got our matrix, this one, which is B. We did one row operation on the elements on this I, so it's called an elementary matrix. Elementary matrix. Now, if you have an elementary matrix, there's 2 row operations on elementary matrices that change the determinant of of an identity matrix, because we know the determinant of this matrix. This one is just a diagonal matrix, as you can see. There's a diagonal here. So the determinant, you just multiply these numbers and you're gonna get that it's 1. So there's two operations that change this. So when you multiply it, okay, and when you swap rows, those are the only two. When you add rows, it doesn't change. So in this case, our determinant for B should be -3 times the determinant of I, which is, we already know, -3. So basically, we're supposed to do this without me even showing you this, because you could tell that, okay, this is an elementary matrix. They multiplied by 3. They multiplied I by 3. So you just go straight and make this your answer. And yeah, 11. Number 11. Oh, my time doesn't seem to be stopping. Maybe I'm doing it correctly now. I'm learning on this zone thing. Definitely learning. Let's cut it. Just happened. Select, cut, select, cut, select, cut, select, cut. Okay. Question 11. Question 5. It's actually a lot of questions on matrices. Question 11. Complete. Suppose that A is a singular matrix that satisfies this. Choose the correct answer. One thing you need to know about singular matrix. A singular matrix, singular versus non-singular, right? Singular matrix is a matrix with no inverse. Then a non-singular matrix is an matrix with inverse, or we call it an invertible matrix. Invertible matrix, right? Another fact on singular matrix, the one with no inverse, we know that the determinant of A is equal to 0, while the one with an inverse, the determinant of A is not equal to 0. These are the facts about singular matrix. Now let's see what we have here. They say it satisfies this. Choose the correct answer. The determinant of A, which is this A, they're saying is 0, or the determinant is minus. Well, this one is correct, and because of this or, it makes the whole statement true, because you already have one that is true. This one is wrong, but because this one is true, it makes the whole thing correct. Then no such matrix. This one is not our best choice, because because they just gave us these matrix. Determinant of A is equal to 1. No, it's not true. This one is not true. So this statement is false. All of the statement is false. Determinant is equal to 1. This one is also false. So this was the correct option here. And we move on to question 12. Right. At 12. Oh, 12 is not matrices. Yeah, we'll take dating. I write on this here. No, I cannot. Paste it. Right. The augmented matrix of the system with no solution is given by, well, if there is no solution, you go towards the last rows. Okay, this one has zeros. So this one cannot qualify. We move on to the next one. This one also has zeros. Oh, look, has a 0 and then it has a number. So we just did this. If there's a 0 and then there's a number, it means the system has no solution. So this is the correct one. Let's see about this one. Okay, we ignore this one. We are just looking for one where there's a 0 and a 1. This one might qualify, but let's see what B is. Is B 0? Oh, B is not equal to 0, so this one cannot qualify. Let's look at this one. No, this one cannot qualify. So the correct option here is this one. So this makes this one wrong. It's this one. Let's go to dating. 14, sorry. Part 14. 18. This 14. 14. 15. 16. 17. Like there's only one left. Yeah, there's only one left, and it's this one. 27. Oh, there's two. 26 and 27. Yeah, start with 26. What is 26 sign? Find the general form of the matrix that commute with this one. So you need to understand what this question is asking for. It says you must find the general form of the matrix that commutes. Basically, remember we have AB is not equal to BA, right? In general. So in other words, AB does not commute with BA, because if it did commute, we would have under certain conditions, let me just say under certain conditions. Now commute. But under certain conditions, if they do commute, AB